Okay, so number 1, simplify each expression. We're just going to cancel stuff out from the numerator and denominator. So first of all, 9 and 27 can both be divided by 9, so we'll take that factor out. 9 divided by 9 is 1, 27 divided by 9 is 3. And then as far as the variables go, we are going to cancel stuff out. There's 2 A's here, 4 A's here. So both of these will cancel and we're left with just 2 A's there. Then all of these B's will cancel and we're left with 1 B and then a C. And then whatever's left over, you just write that out. So 1 over 3A squared BC. We're done. And then this is what you'd look for in the answer choices. And the test will be multiple choice, as usual. Okay, number 2, we're going to break that up into factors and then cancel factors. With number 2, there is a coefficient in front of that k squared. When there's a coefficient, you have to do the ACB thing to factor it. So A times C, negative 30, B, negative 1. I need 2 numbers that multiply to this one and add to this. So that would be negative 6 and 5. And then writing out the factors, 2k minus 6, 2k plus 5. And then take out any common factors here. And divide both of those by 2. Get k minus 3, and then 2k plus 5. So these are the 2 factors that would make this, and I'm just going to write that out. Trying not to cover it with my hand, but it is kind of covering it. Okay. There's the 2 factors there for the numerator. And then k squared minus 9, this format comes up a lot. It's just k plus 3, k minus 3. Then once you have it broken up into factors, you can cancel anything that's in common. So k minus 3 just cancels and we're left with just this. And that is the actual answer. So the answer here is 2k plus 5 over k plus 3. Okay, number 3, similar, we're just canceling stuff out. We have multiplication, so we're good. So it means all this is multiplied by all this is multiplied by all this. We're just going to cancel anything that is in common with the numerator and denominators. First off, the 15 and 25, those both have a common factor of 5, so I will divide both by 5 to get 3 and 5. The negative 2 and 14 can both be divided by 2, so I'll divide this by 2 to get negative 1, divide this by 2 to get 7. Okay, now I'm going to simplify the variables. U cubed and U squared. So there's 3 U's here, 2 here. So both of these U's would cancel and we're left with just 1 U on top. The Y, we have Y and then 2 Y's down here. So this would cancel and we're left with 1 Y on the bottom. The X cubed and X. So this would cancel and we're left with 2 X's. And then Z to the 5th power here. So then we just take out take all our leftovers and put them together. So negative 1 times 5 is negative 5. We're left with a U and X squared on top. And then on the bottom, 3 times 7 is 21. We have 1 Y and then Z to the 5th power. And that is our answer. Okay. Number 4, find each product or quotient. That's very similar to what we did up top. We have to break everything into factors and then cancel out factors. Just one part at a time. So 3y minus 9, I'm going to take out a 3 there. Then for the bottom, 2 things that multiply to 20 add to negative 9 would be negative 5 and 4. then factoring this, -4 and -4 would multiply to positive 16 and add to -8. So y minus 4 over y minus 3. Okay. Step 2, cancel anything on that repeats on the top and bottom. So y minus 3 cancels here. You can cancel y minus 4. And take the leftovers and just write them together. So 3y minus 4 over y minus 5. You're done. Okay, number 5 is similar to number 4. The only difference is this division symbol right here. We can't do what we just did until everything's in multiplication. So in order to get this to multiplication, we're going to do keep, change, flip. Keep the first fraction, change the sign to multiplication, and flip the second fraction. So just rewriting it, keep the first one, change the sign, flip the second one, and then I'm going to factor stuff out and see what cancels. Yes.
How do I know when I have to use keep, change, flip?
When it has a division symbol.
Okay.
Yeah. Okay. Now that everything's in multiplication, you can cancel stuff out. So cancel this with this, this with this. Okay, cool. We're just left with a 4 and a 2. 4 times 2 is 8. Okay, so all the questions above were multiplication and division, and they followed pretty much the same process. Now we're going to get into some subtraction and addition. When you're subtracting or adding fractions, you need to have a common denominator. So we're going to be working on getting a common denominator and then simplifying. So for number 6, 6ab and 8a. This here needs a b, and this value also has to be the same. The least common multiple of 6 and 8 would be 24. Like I can multiply this by 4 and multiply this by 3 to get 24. So I'm going to multiply this by 4, and whatever I do to the bottom, I do to the top. And then this will multiply by 3b, because we'll get the 24, and it'll also be ab. And then whatever you do to the bottom, you do to the top. Then we're going to rewrite this all out with the same denominator. 4 times 5 is 20 over 24ab minus 21b over 24ab. Last step, now that we have a common denominator, we can combine like the top portion. There's nothing we can do to simplify that, but we're just going to put it together. Whoa. That's hard to read. Okay, I'm going to rewrite that. 20 minus 21b over 24ab. And this is the answer you would be looking for in the answer choices.
If you can't simplify it anymore, you just leave it.
Yep, you just leave it. Okay. Next one, same idea. We need a common denominator. Here, 5 and 12, the least common multiple would be 60. So we're going to multiply by something to get 60, and then this needs a couple more y's. This needs a couple more x's. So here we'll multiply by 5y squared. That'll give us 60, and then the same number of y's that are over here. Oh, sorry, you can't see it. 5y squared. Then whatever you do to the bottom, you do to the top. Is my watch going crazy? Oh, okay. Then over on the other side times 12x squared. And that would give us the same amount of x's as the other side, as well as that 60 on the bottom. And then whatever you do to the bottom, you do to the top. Okay, now I'm going to rewrite it all out. 5y squared times 5, 25y squared over 60x to the fourth, y to the third, minus 12x squared over 60x to the fourth, y to the third. And then, now that we have the same denominator, I'm just going to rewrite this. This is what you'd be looking for in the answer choices. And that's it. There aren't any common factors between 25 and 25y squared and 12x squared that you could take out. So that's it. Okay, next one gets easy again. Number 8, find each sum or difference. We already have a common denominator, so that means we can just add the two numerators. 7u plus 5u would be 12u over 16. And then simplify. 12 and 16 can both be divided by 4. Get 3, 4, 3u over 4. Done. That's it. Okay. Then number 9. Again, subtracting. We need to have a common denominator. Got 5x squared and 3x. So least common multiple would be 15 of 5 and 3. So multiply this by 3. And then multiply this by 5x and 5x. Get 18p over 15x squared minus 10xp over 15x squared.
Did you say px or does it have to be?
It doesn't matter, yeah. I guess px may be better. I don't know. 18p minus 10px, because she says it. Normally it is in alphabetical order, so you're good. 15x squared. Okay, something you may notice is in this one, you could pull out a common factor here, 2p, from both of those terms, but if you did pull out 2p, it wouldn't cancel anywhere, so it would be kind of pointless. Okay, now number 10, same idea. Now we need to get factors of this. Y squared minus 16 would be y plus 4, y minus 4. And then the factors of this would be y plus 4, y plus 4. We need to have a common denominator, and the difference here is we have 2y plus 4 is here, and then y minus 4 here. So this over here needs a y minus 4, which you have to do this. And then this one over here needs another y plus 4.
Where'd you get the y plus 4 and y minus 4 from?
I needed a common denominator. And the difference between these is this had a y minus 4 and this didn't. So it needed a y minus 4. And this one had an extra y plus 4. So I needed to add that over here. And whatever I do to the bottom, I do to the top. This one is a longer problem, just FYI. Okay, so now that we have a common denominator, I'm going to kind of set that off to the side and put that on at the end. So just kind of circling it. I need that for my final answer. But for right now, I'm going to focus on this top part. In order to multiply this by this, I do have to FOIL it. So I'm going to have to FOIL this, and I'm also going to have to FOIL this. Okay, but we can do it. Okay, so we're going to FOIL this and just write all the terms out.
Why did you multiply y plus 4 the denominator for that 4?
because this one had 2y plus 4s, so this one needed 2y plus 4s. Okay, now I FOIL. So y squared plus 4y plus 3y plus 12 plus, okay. I'm trying to like zoom in and also show everything at the same time. Okay, so I just FOILed all this. Now I need to FOIL all this. 3y squared. And I'm going to make a second row here. I know that's not what you're supposed to do with math, but do what you got to do. Outside. Negative 12y minus 2y plus 8. Okay, so these two rows, I need to simplify this by combining like terms. So I'm just looking for matches here. I got a y squared and a 3y squared. That would be 4y squared. Then I'm going to combine all the y's. Got this 4y, 3y, negative 12y, negative 2y. I add all those y's, and it comes out to negative 7y. And then last but not least, 12 plus 8 is 20. And then I take this fancy equation and put it over my denominator. Y plus 4, y plus 4, y minus 4. We're getting smart. Okay, so that's your answer. As far as the answer key and what the correct answer is in the answer choices, they wrote it like this, but I think you could just recognize that. If you got this far, you could easily recognize this in the answer choices as also correct. So the answer key just took the y plus 4, and wrote it as y plus 4 squared. Okay, next. Okay, 11. Same idea. This one's a little bit simpler though. Break this up into factors. So 2 numbers that multiply to this, negative 5 and 2. So y minus 5, y plus 2. And this would be positive 2, negative 1. Y plus 2, y minus 1. This one, there's actually a shortcut. So this up here is y minus 5, and right down below it is also a y minus 5. So we're going to take a little shortcut and just cancel y minus 5 and y minus 5. Okay, now to continue with the problem, we do need common denominators. So y plus 2 matches, but this has an extra y minus 1, so I'm just going to multiply a y minus 1 here and a y minus 1 up here. So technically there's like just 1 left there. Oh, sorry, didn't realize it was too zoomed in. Okay, so to make the denominators match, put a y minus 1 here, and whatever you do to the bottom, you do to the top. Okay, now I'm going to write it all out. So we have a y minus 1 on top, plus this y over y plus 2, y minus 1. We can combine these like terms to get 2y minus 1 over y plus 2, y minus 1. And we're done. Okay, we're going to skip these for now, go to the graphing, and then if we have time, we go back over up here. So 17, graph each function. So for these, the way we did it yesterday, we needed a vertical asymptote, horizontal asymptote, x-intercept, and y-intercept. so vertical asymptote, you just take the denominator and put it equal to 0 and solve. So x minus 2 equals 0. So x equals 2. So vertical asymptote is that x equals 2. Then for horizontal asymptote, you look at whether this is top heavy, bottom heavy, or the same. And in this case, it's bottom heavy. Call it bottom H. And then according to our notes, and you could just make a note of this on your practice test if you wanted to, if it's bottom heavy, then the horizontal asymptote is at y equals 0. So y equals 0. Okay, and then for x-intercept, I'm going to show you, there's actually no x-intercept here. Remember, for x-intercept, we put a 0 here, and then we solved it, but since it doesn't work out. So here, when we do our horizontal asymptote, it'll actually land on the x-axis, and no point lands there. So there is no x-intercept. And if you were to solve it, you'd find that out. It doesn't even work out. Then for y-intercept, we plug in a 0 for the x here. So y equals -4 over 0 minus 2. And we just solve. So this would be -4 over -2, which is 2. So y equals 2, and the coordinates would be 0, 2. Okay, and then using that information, we're going to start graphing. So on your half sheet of paper,
You can go back to that.
yeah. Okay, so we're going to just draw a coordinate plane. Ooh, try to draw it straight. That would be helpful. Okay. Okay, so right now I'm just drawing a coordinate plane. Okay, cool. Okay, so from the information we got vertical asymptote is at x equals 2. So x equals 2 would be right here. And we're just going to draw a vertical dotted line. It's like our guideline. It can't cross it or touch it. It's just a guideline. And then horizontal asymptote is at y equals 0. So your horizontal asymptote is this axis. I guess I could like kind of draw it right above so you can see. Okay. There's our asymptotes, and then we have a y-intercept as 0, 2. So I'm going to use pencil at this point. 0, 2. Okay. Cool. Okay, we need more points, obviously, to actually graph this thing. So we're going to make a little chart, x and y, and we're going to choose numbers that will help us. So as far as x goes, I might choose 1, because I need a point like right here. And then over here, maybe -3 sounds good, because I'd be able to graph it like this. And then the other part of the graph is going to be down in this quadrant. So maybe +3 would give me a point. And then maybe 5. Okay, so there's the x values that I want. I want to know where the y value is, and the way we do that is we take the equation and plug it in. So the equation they gave us was f of x equals -4 over x minus 2. So I'm going to plug these values in. So I get a 4. So 1, 1, 2, 3, 4. Cool. Then -3. You get 4/5. Or 0.8 if you like to see numbers in decimals. So for -3, 1, 2, 3 is at 0.8 right here. Which makes sense because this is kind of what I'm going for. Okay, we got that portion graphed. And now we need to graph this portion here. So using these numbers, again, plugging it into the equation. -1.3 repeating. There it is. Okay, so there's a graph that you'd be looking for in the answer choices. This is 17. 17. Okay, 18, same process, same thing. So for 18, we'll do it again. Oh, you guys are still graphing. 18. Same thing, I'm looking for vertical asymptote, horizontal asymptote, x-intercept, y-intercept. So vertical asymptote, I would do x minus 2 equals 0, so x equals 2. Horizontal asymptote, looks like the x's are the same, so therefore take the coefficients, which are just 1, 1 over 1 equals 1, so horizontal asymptote is y equals 1. Then for x-intercept, put a 0 here. The denominator cancels out, and you're just left with 0 equals x minus 3. So x equals 3. X-intercept would be 3, 0. And for y-intercept, do y equals 0 minus 3 over 0 minus 2. -3 over -2 equals 3 halves. So we get 0, 3 halves. Okay, now I'm going to graph this and see what else I need. So on the graph paper, you can use the back of your graph paper, wherever. Got my graph. Okay, cool. Okay, vertical asymptote is at x equals 2. So that would be right here. And horizontal asymptote is at y equals 1. So right here. Not it. Who's that? Okay. And then x-intercept is at 3, 0. 3, 0 would be right here. Y-intercept is at 0 and 3 halves. 3 halves being 1.5. Okay, obviously I need more points to actually graph this, so setting up a chart here. I'm going to grab a couple numbers from over on this side, maybe 1, and I don't know, maybe -3. And then over on this side,